Today's topic is weather fronts. What is a weather front? A weather front is the principal cause of our climate. It allows us to predict the weather through the use of surface weather analysis. In surface weather analysis, fronts are depicted with various colored lines and symbols, depending on the type of front. There are 4 types of fronts. They are stationary fronts, cold fronts, warm fronts, and occluded fronts. Now let's look at stationary front. A stationary front has little or no movement. It is denoted by alternating blue triangles and red semicircles. The weather is stable. It is clear, partly cloudy, and little precipitation. Usually it is nothing severe. Now if the stationary front starts moving south, it will become a cold front. And if it starts moving north, then it will become a warm front. Cold fronts occur when a cold air mass advances, replacing and forcing up warm air. At a cold front, the cold air is behind the warm air. Because the cold air is more dense, it pushes the warm air out of its way, forcing the warm air to rise into the atmosphere. As the warm air rises, it cools. The water vapor in the air condenses out and clouds start to form. The warm air is forced to rise rapidly because of strong undercutting by the cold air. This causes towering clouds to form and thunderstorms. Heavy precipitation is usually associated with cold fronts, but it is short-lived and only affects a small distance, about 50 to 70 kilometers. Now let's look at warm front. Warm fronts occur when a warm air mass approaches a cold one. The warmer air lifts up and over the colder air. Warm fronts generally move more slowly than cold fronts, gently settling over the cold air and moving it out of the way. At a warm front, the air behind is warmer and more moist than the air ahead of it. So warm fronts generate light rain or snow which can last from few hours to several days. Lastly, let's talk about occluded front. Occluded fronts occur when cold front catches up with warm front. There are 2 main types, cold and warm occluded fronts. The difference depends on the relative states of the cold air masses behind and in front of the warm air. In a cold occluded front, the air mass overtaking the warm front is cooler than the cool air ahead of the warm front, and plows underneath both air masses. So the weather associated is similar to a warm front as the occluded front approaches. Once the front has passed, the associated weather is similar to a cold front. On the other hand, in a warm occluded front, the air mass overtaking the warm front is not as cool as the cold air ahead of the warm front, so it's not dense enough to lift cold air ahead of warm front. The cold front then rises up and over the warm front. The weather associated is similar to that when a warm front passes.